lesson for today because this is review material that we have to have for our lesson for today. When we're finding the median of a set of data points, what is the first thing that we must always do? Michael?
List them from lowest to highest?
Yep, from least to greatest, lowest to highest. So I'm going to put them in order first. What am I doing as I go? Rebecca? I'm crossing out the numbers. Why is that important? Maureen? Yeah, so I won't put the same number twice. And also, when I get to the end, I need to make sure that all numbers are crossed out. If I haven't crossed out all numbers, that means I might have missed one. What's another way I can check at the end whether I got all my numbers written down or not? Rebecca? Yep, count them up. I had 1, 2, 3, 4, 5, 6, 7, 8 numbers, and I have written down 1, 2, 3, 4, 5, 6, 7, 8 numbers. Good. How do I go about finding the median? Nicole? Yep. 2 at a time from the outsides until we get to the middle. Now, sometimes we have a median that's just a singular number. Sometimes we have what is called a split median. We have to have the same number of crossouts on both sides. So I can't do any more crossouts without crossing out all of the numbers. So this is what we call a split median. We're split between 6 and 8. Who remembers what we do with a split median to get our single value? Christopher? Yep, so we have 6 plus 8 is 14, and we divide by 2. That gives us C, 7. All right, so that's our review for a median. You'll see within our aim for today, we're going to be asked to find the median, which we've just reviewed, the maximum, the minimum, the lower quartile, and upper quartile of a set of data. That's a lot to find. However, we already know how to find median. Maximum and minimum, I think most of you probably already know what that means. If not, you'll catch on exceptionally quickly. So the only thing we're really worrying about is being able to find these lower quartiles and these upper quartiles. So that's going to be our main focus of our work for today. The way that I want us to get started thinking about quartiles. If you take a Snickers bar, and you break it into half, and then you break it into half again, what are you left with? If I take a Snickers bar and I break it into half, then I break it into half again, what am I left with? Malcolm? 1/4. So if I take it, I can break it in half, and then I break it into half again. I end up into quarters. Okay? So when we're talking about this particular thing, when we're breaking our data into half, that middle cut is our median. Okay? So we're kind of comparing our Snickers bar to what we're doing with our data sets. Before we look at what happens with these other two cuts, let's talk about money. If I have $1 and I split my dollar between Adriana and Graciela, but then Adriana takes the money that I give her and she splits it in half. And Graciela takes the money that I give her and she splits it in half. How much is in each of their piles? So first of all, how much did I give Adriana? 50 cents. Adriana splits up her money. How much are in her 2 stacks of money? 25 cents. What do we call a 25-cent piece? A quarter. So, this is where the idea of quartiles come from. It's breaking our money or breaking up our data into 4 parts. So over here, this cut right here of the lower half of the data is called our lower quartile. So when we're talking about our Snickers, that's like we can picture, that's this red cut. That's our lower quartile. We took the lower half of the Snickers and we cut it in half. That's the lower quartile. That cut the lower half into quarters. Upper quartile, same thing. We're going to take our upper half of the Snickers. That's going to be our other cut. So let's get some definitions going here. Median. What do we think a good definition for median is? Michael. Yep, it's the number of the middle. That splits the data in half. What about lower quartile? Anybody got a good sneaking definition of that? All right, I'll give you a lower quartile because I'm feeling so generous today. So with lower quartile, we took the lower half of our data, or our lower half of our Snickers bar, and we found the median. So the lower quartile is the median of the lower half of the data. Upper quartile. This one should be easy now that I gave you the definition for lower quartile. Which means more than, there we go. There's a couple more. Kendrick. Perfect. Median of the upper half of the data. So if we have these definitions in mind, and we have these memorized, that pretty much tells us exactly what we need to do to find these particular pieces of information. There are just a few small details that we need to catch. Maximum and minimum. Katie. We've got definitely the right ideas in here. You're talking about range, which has to do with maximum and minimum. She's telling us that the range is taking the smallest number and subtracting it from the largest number. The maximum and the minimum are what parts of that, Rebecca? All right, so the minimum is our smallest number. The maximum is our largest number. So I have taken the data from our geometry tests, multiple choice portion, And I have taken out the subsection here of people whose last names are S through Z. And I want to go ahead and label on this what these different arrows represent in the data. So the arrow on the far left represents what part of our data? Which of these 5 vocabulary terms does this very first arrow represent? Sarah? Minimum. So you're going to label that as the minimum. Which means the one on the far right must represent our maximum. The one in the middle probably represents our median. And between the minimum and the median is the lower quartile. This is the lower half of our data. Which means this last piece must be the upper quartile. Excellent. Moving forward, let's see an example here. Here are the geometry test scores for multiple choice scores for students' last names R and S. So if you have last name R and S, your score is in here somewhere for the multiple choice portion. What's the first thing that they need to do with this data set? If I want to find median, quartiles, and maximum and minimum, first thing I need to do, Janelli. Order them from least to greatest. That is the first thing that I'm going to do. Notice again that as I go through and rewrite the data, I am crossing them out. No mistakes. Two 21s, make sure that you don't miss 2 of those. There's 2 24s and 2 25s. Ah, good, 3 25s. First thing Ness is to do is find the median. So just as we said during the do now problem, we're going to start with the outsides and take out in pairs. Outside, outside. That's 2, 3, 4, and 5. I have exactly 1 number in the middle. That's nice and easy, so that is our median, 21. So the next question says, what does that really mean though? In real world terms, that tells us that half of the students scored above / below 21. So half of the students scored above 21, half of the students scored below 21. All right, so find the lower quartile. This is one of the important pieces here. So when we find the median, this median is going to chop up this number, which means that's not going to be part of our data for our lower half. So when I use my lower half, I'm going to box in my lower half, and this is going to be what you need to do to make sure that you're showing me you know what data you're working with is your lower half. Because that median split right through that one number, that number can't be a part of our lower half or our upper half. I'm going to take my lower half, Do the same thing before. Outside, 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 outside. One number left over in the middle. 16. What does that really mean? That means 1/4 of students scored lower than 16. All right, upper quartile. Am I going to include this 21 in my upper half of the data? If yes or if no, am I going to use this 21 in the upper half of my data? No, it got chopped up. Outside, 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 outside. One number directly in the middle. Upper quartile is 25. What does that mean? What do we think that means in the real world, Manuel?
1/4 of students scored over 25.
1/4 of students scored higher than 25. Hinger than 25. Higher than 25. Find the minimum. What's the minimum? Jose, what's the minimum? 10. That means the lowest score was 10. What's the maximum? Brian, what's the maximum? 25. So that means, what that means in the real world is the highest score was 25. I want to get through one more example. And I'm going to move quickly through this first part. First part me is to do what? It's the first thing I need to do. Kendrick? Least to greatest. Oops, looks like there should have been a 17 there. I'm going to quickly recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Thinking about how many number of data points are in this set. How many data points are in this set? How many data points? Rebecca? 16. How is that going to make this different than the previous problem? Oh, wow. It's going to have a split median because it's an even number of points. So that's going to be a little bit different. Outside, 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 outside. 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8. A split median. So I have to find out what's between 20 and 21. Well, it's really nice when they're consecutive numbers because we know what's going to be directly between those consecutive numbers. Yeah, so 20.5. There's really no need to add and divide when they're right next to each other. So what does this really mean? Half students scored above / below 20.5. All right, this next one's an important detail for you to catch when we're dealing with lower quartile or quartiles in general. If I'm dealing with quartiles and I have a split median, look at where I drew that line for the median. The median splits those two numbers, which means it doesn't chop those two numbers up, which means they are eligible to be part of our lower half. Notice when I draw my box, I'm including those two numbers that got split. They didn't get chopped up by our median. They got split in between the two of them. So they are part of our lower quartile. Which gives me a split lower quartile. These are not two consecutive numbers, 14 and 17. What do I need to do? Fernando. Got to do something first. Got to add them together so I can divide them by 2. So it's going to give me 31 divided by 2 is going to be 15.5. One-fourth students scored below 15.5. Moving on to upper quartile. Am I going to include this 21 over here? Kip, yes or Kip, no. Am I going to include this 21 over here? Right. It got split in between it. It didn't get chopped up, so I'm going to put my box all the way around and find the median. Out, out, 2, 2, 3, 3. I have a split quartile. Good news, though. They're right next to each other. So, Maureen, if they're right next to each other, 22 and 23, what's in between 22 and 23? $22.5. Saves us some time. One-fourth of students scored above 22.5. Minimum, Marlon? Minimum? That's the minimum? Smallest number is 22.5?
9.
9. And maximum, Gene? You should have your numbers in order from least to greatest, so you should be able to look at the end. Oh, Gene, sorry, you said it? What'd you say? Hilda, what'd he say? 25. Gene, don't be shy. Don't be shy. Come on now. All right. So let's look over here at our together time. With our together time, I would want us to have time to get through this, but we don't. I'd rather you get your alone time done and show me what you've learned today without being able to practice with your teammates. And I know that's a little bit unusual.